Okay, so according to this schedule, we already finished week 5, and then we're gonna begin week 6 material, which is gonna be due exactly a week from today. So tonight we will do the week 6 sections, and whatever we don't finish here, you will do on your own time. And then on our next meeting, I will choose which labs we'll do together. So, and if we have time, if you want, we could also look at the last problem of Amir's homework, because I know we haven't gotten around to that yet.
Yeah, that would be great.
Okay, so maybe we can. Let me see if I can find Amir's homework again. Unless someone wants to post a link in the chat. That'd be cool. Because I haven't looked at the 4th problem. I don't know how long it would take. So. Okay. So Jose Garcia said, I noticed that all the labs are required this week. Will that be corrected by next week when you decide which ones to keep? What exactly, which labs are you talking about, Jose Garcia? Because if you're talking about the week 5 stuff, that was due, because the week 5 stuff was due already.
Oh no, for week 6, if you scroll down the bar, you'll see all the labs are unlocked. Well, not like in the actual thing, but looks like they're all unlocked. Like right here where it says my class.
You're talking about these labs, right?
Yeah, but if you like go to my class and or assignments, assignments, and you scroll down week 6.
Yeah.
You'll see that, and it looks like they're all required. That's what I think Jose's talking about. That's what it looks like, even though they're not obviously all unlocked.
And no, I choose which ones to show, and then.
Yeah, I think it was just confusing.
Yeah, there's excess labs because I choose.
Yeah.
Because the instructor chooses which ones they want.
Yeah.
It doesn't normally show that. Well, it's not practical for me to show you every lab. Right. You know what? Let's just do the homework first, and then we can do the sections after. I think that's what you guys are here for, right? Yeah. So. Okay. So everyone take time now to pull up the homework and on your screens. Brandon Vasquez asks, you good? Yeah, I'm fine. Why? Okay. All right. Oh. I don't want to do that. Oh shoot, how do I? Okay, so question 4 says, translate the following pseudocode for finding the minimum value from a set of inputs into a C++ program. Okay, so let me first write my normal C++ jargon, and then we can start reading the pseudocode together. So here I will include IOStream using namespace standard int name. Okay. Okay, so this question looks pretty easy. I would argue that it's probably the easiest question in this homework. But yeah, we can look at it together. So the first thing it says is set a Boolean variable first to true. Right? Now everybody understands what a Boolean variable is. It's a true-false variable. It could hold the value of true or false, right? Okay. And then now it says while another value has been read successfully. So so this says while another value has been read successfully, and while that statement is true, we will do the code that's inside of the while loop, right? So we're going to say while here. I'm not quite sure yet what to put inside the parentheses, but
maybe while bool is true, would that work or no?
While first is no, because well, actually I don't know actually, because it says while another value has been read successfully. I'm not sure how to communicate that to the code, because how would you know when all of the values have been inputted already? Okay, well, we can figure out what to put in here later. Let's just continue with the pseudocode. So inside of this while loop, we have this here. One is going to be an if and then an else if following, right? So if first is true, so I'm going to put first inside of the parentheses of the if, because that's all I need in order to get the, because inside of the parentheses, I need a true false statement. And if I'm putting a bool in there, a bool is already a true false statement. So I can just put the name of my variable in there. And then, yeah, that's all I need. And then else if the value is less than the minimum. Okay. Oh, so Logan Ashbaugh says in the chat, while cin variable. Is that how you do it? And then I'm gonna need to make an int called variable. Like that. Logan Ashbaugh says, yeah, I think if you declare the variable as an int and put an input a string, the while loop will exit. So how would this while loop know when to stop when I put in a string? Are you saying it'll stop when I put in a string as an int, because that will be invalid? Because you think so? Because I've actually never tried something like this before. With a cin, return a true or false statement? Huh. Well, I guess we'll only find out if we run it. But thank you for telling me, Logan Ashbaugh. So all right, here's what we got to do. I'll put parentheses here. I'll fill this in later, but it says if first is true, I have to do these things. The first thing I'll do is set the minimum to the value, and then set first to be false. Set the minimum to the value. So I guess we're gonna make well, just so it reads a little better, I guess I'll change the name of this variable from variable to value. And then I'll put this again over here. And then I'm gonna need another int statement to hold the value of minimum, right? So I'm gonna say int minimum. And Jose Garcia made a very important note in the chat. He said, I never initialized the variable first. I need to set that to be true. Thank you for catching that, Jose Garcia. True. Because if it's not true, it'll try to evaluate it. And since it's going to try to evaluate an undeclared variable, it would cause some problems, right? All right, so if first is true, we want to set the minimum to the value. So I guess minimum is going to be equal to value, like that. And then after that, we also need to set first to false. Okay. So first equals false, like that. Okay. And then if this evaluates to be false, we have an else if that we need to okay, Jose Garcia asked a question in the chat. He said, also, is the else if necessary? If it's either true or false, it would just be false, right? Yeah. Well, I was just going off of the pseudocode here because I just decided to write else if because it said else if. But you are right. We don't need if a value can either be true or false, and you know it's not true, it has to be false, right? So I guess I can remove the else if and just put else instead. Thank you, Jose Garcia. Okay, so else if the value is less than the minimum. Actually, no. I think I actually do need the else if, because here's the thing. when it's false, yes, we're going to ignore this, but we need to consider the situation where the next value we see is going to be less than the minimum. Because if it's more than the minimum, we can ignore the code that's in here. But if it's less, then we actually need to do something, right? So else if value is less than the minimum. So value is less than. Okay, so the way if statements work is that it does its checks sequentially. So it'll check if this is true first. If it turns out to be false, it'll check if the next one is true, right? Now, the reason I had to put an else if here is because there's two other situations. If it turns out that the first variable is not our minimum, after that, it's going to be checked. It's going to be set to false, and then it'll do this check for each other iteration, right? There's two possibilities that will happen when we check the next number. Either the next number is going to be greater than the minimum or less than the minimum. If it's greater than the minimum, we don't want to do anything at all. That's why I don't have an else if value greater than minimum. But when the value is less than the minimum, that's when I want to do something, right? In this situation, I need to set the minimum equal to the value, right? So minimum equals value. Like that. So all of this looks like it's good. But now, the last thing I need to do is print the minimum. So eventually, after I stop entering values, this while loop will finally end. And then I need to print the minimum value that I found, right? So the last thing we'll do is cout minimum, right? So to those who already did the homework, did you get a solution that looks almost similar to this? Anyone? Yeah? Okay. Well, there's only one way to find out if this works or not. So let's go ahead and run it. Okay. So right now, the program wants me to enter some values. So I'm just going to enter some random integers here. So maybe I'll say 5, 9, 3, 8, 7. And hopefully it'll output the minimum that of these 5 values I put and say 3. So in order for the while loop to stop, I need to enter something that's not an integer. So maybe, yeah, it gives 3, which is the minimum of these. You know, I've actually never seen a while loop being used like this before, where a cin can be interpreted as a true or false value. So that's interesting. I'll remember that for my other programs. But do you guys understand what's happening here? If you want, I can debug it, and then we can understand the logic together. So I'm going to step through this program line by line. So, all right, so we are on line 11 right now. It wants me to enter a value. So I'll maybe put 8. Okay. So 8 is my first value, right? When it does the iteration, because first evaluates to be true, it'll execute these lines of code and ignore this one. So my minimum right now it's not initialized to anything, but when I step to the next line of code, it'll evaluate to be 8. And then it'll change when I step to the next line of code. First will change to false. So that means from now on, when I do the iterations of the while loop, this code will be ignored, and it'll only do this code, provided this is true, of course, right? So I'll step. So it wants me to enter another value. Let's enter a value that's higher than 8. So maybe I'll say 10. Say 10. No, 110. That's just as good. So, when I enter the while loop again, because first is false now, this code will be ignored, and it'll jump straight to this. Now, this code will only execute if value is less than minimum. Right now, if you look at my auto screen, minimum is 8 and value is 110. So because 110 is not less than 8, this code will be ignored. And that's the reason why I can't have a else in there, right? I need an else if. Okay, so in this iteration, I didn't do anything because the next value I saw wasn't lower. But this time, let's enter a value that is less than 8. Maybe this time I'll say 7. Okay. So again, first is still false. So this code is ignored. So we jump straight to here. Now, value, else if value is less than minimum. Right now, value is equal to 7. Minimum is equal to 8. Because 7 is less than 8, this code will execute. And as a result, we set minimum equal to our value. So minimum changed from 8 to my current value, which is 7. Okay. Now it's gonna, next time it iterates, it wants me to enter another value, but I'll just enter a string like that. That way I'll exit the while loop, and then it see outs my minimum. My minimum is 7. So it'll see out 7. All right, make sense? Does anybody have any questions, or are we good? It's pretty. It's a pretty good homework problem. I mean, I definitely learned something from this. I never knew that you could do this with a while loop. So if everybody got this, or everyone who needs it already got it, we can move on. Oh, Slayman Toki says in the chat, I run it and it looks like nothing pops up. Okay. Slayman Toki, do you want to share your screen, and then we can try to find your problem together? Okay. Let me stop my share and give you permission to share your screen. All right. Go ahead. Okay. Okay, so that looks good. That looks good. If first values. Yeah, your code looks fine. I'm not quite. Oh, you have to enter some values in order to. Yeah, enter some values, and then when you've entered enough values, enter a string. There you go. And it returns the 5, which was the lowest of the integers you put. All right. There you go. So are you good, Slayman Toki? Okay, great. Go ahead and stop your share. Don't worry about it. All right, so, all right, very productive. I'm glad we did that. So, so now that we got that out of the way, we can move on to the sections, right? Okay. Let me go ahead and close this. Close this as well. Okay, great. Okay. So now we can proceed with the week 6 material. So, just wondering, what did you guys cover in lecture today? You guys cover functions? You know, user-defined functions is actually one of the most useful things that you could do in C++, because if you're able to, so simple programs up until now have used one function, and that's the main function, right? But if you could, if you're doing a process over and over, and instead of writing the code over and over again, you write a function and then call the function whenever you need to use it, that actually opens up a lot of doors and gives you a lot more versatility when you're writing your C++ programs. So so we're going to go ahead and begin chapter 6 sections and learn about functions now. So 6.1 is about random numbers. So generating a random number. Some programs need to use a random number. For example, a game program may need to roll a dice, or a website program may need to generate a random initial password. Okay. The rand function in the C standard library returns a random integer each time a function is called in the range 0 to rand max. Okay. So, so one thing you need to know about functions is that functions always have a open and closed parentheses in them. If a particular function needs to take parameters, you would put the parameters inside of the parentheses. But if a function doesn't need to take parameters, you would just put open closed parentheses with nothing inside of it, right? So this rand function, because it doesn't take parameters, you just put open closed parentheses. Now this function is a function of the C standard CST-lib library, which I believe stands for C standard library. And it'll output an integer between 0 and rand max. Rand max in this case is going to be equal to this really large number here. So when we called rand the first time, it outputted this. When we called rand the second time, it outputted this. When we called rand the third time, it outputted this. Okay. Now, yeah, we went over this already. Now, here's the first participation activity. It says restricting random integers to a specific number of possible values. So each call to rand returns a random integer between 0 and a large number rand max. Okay. A programmer usually wants a smaller number of possible values for which the mod operator can be used, or modulo, which means remainder. Rand modulo 3 has possible remainders of 0, 1, and 2, right? So depending on what number your rand returned, it could be 0, 1, 2, 3, 4, 5, 6, all the way to some large number. If we mod it by 3, we created a random number generator that creates 0, 1, or 2, right? Thus, rand mod 3 yields 3 possible values, 0, 1, and 2. But generally speaking, rand mod n yields n possible values from 0 to n minus 1, right? So now that we got this, we can do this participation activity now. So what library must be included to use the rand function? Well, we already learned that, right? It's the C standard library. So I'll just click this. The random integer returned by rand will be in what range? It's going to be from 0 to rand max, of course. Which expression's range is restricted to from 0 to 7? It's going to be rand mod 8 because it's always going to be, because n the range is always going to be from 0 to n minus 1. So 8 minus 1 is 7, so it has to be rand 8. And then which expression yields 1 of 5 possible values? It's going to be rand mod 6. Because again, n minus 1 is going to be the max. Oh, excuse me. It's actually going to be rand mod 5 because I forgot to account for 0, right? Which is a possible value. Okay. Which expression yields 1 of 100 possible values? It'll be rand modulo 100, right? Yep. Now, which expression would best mimic the random outcome of flipping a coin? It would be rand mod 2, right? Yep. And then what is the smallest possible value returned by rand mod 10? Well, the smallest possible value for rand mod anything is going to be 0, right? And then lastly, what is the largest possible value returned by rand mod 10? It would be n minus 1, which is going to be 9, right? Yep. There you go. All right. And next section says specific ranges. So the technique above generates random integers with n possible values ranging from 0 to n minus 1, like 6 values from 0 to 5, right? In this case, if n equals 6, our values would be from 0 to 5. Commonly, a programmer wants a specific range that starts with some index x that isn't 0, like 10 to 15 or negative 20 to positive 20, right? So what would you do if you wanted your count to start from a number that isn't 0? Well, the program should first determine the number of values in the range, generate a random integer with that number of possible values, and then add x to adjust the range to start with x, okay? So in the example that I said before, if you wanted to do a range of 10 to 15, you would just make a random number generator that does values 0 to 5 and then add 10 to it, right? So this participation activity shows exactly that. I'm going to put this at double speed so you guys can see. So if we wanted a range from 10 to 15, we would take the max minus the min, which is going to be 15 minus 10, and then we add 1 to it. So there's 6 possible values. Rand mod 6 generates 6 possible values as desired, but it has the range from 0 to 5. So what are we going to do to adjust that, huh? Well, we would simply add 10 to the random number that we generated. So if we take the values 0 to 5 and then add 10 to each of them, we would have values 10 through 15, right? Okay. All right, so this participation activity says generating random integers in a specific range. So goal, we need a random integer from 6 possible values, 0 to 5. What are we going to say? We're going to say rand mod something. I believe this is going to be 6, right? Mm-hmm. Okay. So the next question says we need a random integer from 0 to 4. So going off of the same logic, we need to say rand mod 5, right? Okay. So next question says, how many values exist in the range 10 to 15? There's going to be 6, right? Because 10, 11, 12, 13, 14, 15. So I'll say 6. How many values exist in the range 10 to 100, right? It's going to be 91 because we're including 10 as well. There we go. Now we need a random integer in the range 10 to 15. So starting off, we have rand mod 6. So what would we add to it in order to get to the range 10 to 15? We would add 10, right? Yep. And the next, random integer in the range 16 to 25. So I need to, so in order to figure out problem 6, what I need to do is find out how many numbers are from 16 to 25. How many is that? 10? Mm-hmm. And then next, how many values are in the range -5 to 5? Now this might trip you up because not only do you need to include -5 and +5 as possible values, you need to also include 0. So how many values are in this range? Anyone want to enter in the chat and guess? I think it's going to be 11. So let's try 11 and check. Okay. And then lastly, we need a random integer in the range -20 to +20. So here we're going to say rand for mod 41 plus what value? I think the value for question 8 is going to be minus 20. So let's check. Yep, because we need to shift the 0, 20 values to the left. So that's why we subtract 20, right? Okay. So here's another participation activity. So which generates a random integer in the range 18 to 30? Okay. Does anyone know? Well, it would be rand mod n minus 1. So in this case, n is our n is 30, but we need to subtract our starting point, right? It's going to be 18. And then I say we have to move 18 values to the left. Oh, it's this one because we have to add 1 as well. Thank you, Slayman Toki. Yeah, I forgot to do the +1 at the end. Okay. So far so good. So here's another sample program. So the following program randomly moves a student from one seat to another seat in a lecture hall, perhaps to randomly move students before an exam. Okay. The seats are in 20 rows numbered 1 through 20. Each row has 30 seats numbered 1 through 30. Okay. So in total, there's 600 seats. All right. The student should be moved from the left side, columns 1 through 15, to the right side, columns 16 through 30. Okay, so this program does exactly what the comments say. Switch a student from a random seat on the left to a random seat on the right. Seat rows are numbered 1 through 20, okay? So it declares 4 integer values. Row num, so row num left, col num left, row num right, col num right. So row num left is going to be equal to rand mod 20 plus 1. This would give us a value from 1 through 20. This will give us a value from 1 to 15. This will give us a value from 1 to 20. This will give us a value from 16 to 30, right? So that's a practical application of the rand function that we learned, right? And then next, consider the above example. The row is chosen using rand mod 20 plus 1. The 20 is because 20 rows exist. The plus 1 is the plus 1 necessary or optional? Say in the chat what you guys think the correct answer is. If you think it's necessary or if it's optional, the plus 1 in these equations. Well, obviously it's necessary, right? Because the way that rand usually works is that it gives us values from 0 to n minus 1. But in this situation, there's no such thing as a row 0. There's no such thing as a column 0. That's why we have to transcribe everything over by 1, right? Now, next question says, the column for the left is chosen using rand mod 15 plus 1. The 15 is used because the left half of the hall has 15 or 30 columns? Well, it already stated in the code that the left half has 15 columns and the other 15 is on the right, right? So there. And then the last question says, the column for the right could have been chosen using rand mod 15 plus 15. Now, this one's a good one. So, because this might trip you up. So how many of you think this is true and how many of you think this is false? Say in the chat which one you think it is. False? Yeah, it's false because what were we missing, right? It says the right columns are numbered 16 to 30, and rand 15's range is 0 to 14. Adding 15 would have yielded 15 to 29. So just keep that in mind if you're writing a program that requires a random number generator. If you say n possible values, your range is always going to be from 0 to n minus 1, if I can find that formula again. Yeah, 0 to n minus 1. That's why we had to go a step further in order to get 16. But now, next we have this section here. Pseudorandom. The integers generated by rand are known as pseudorandom. Pseudo means not actually, but having the appearance of, right? The integers are pseudorandom because each time a program runs, calls rand to yield a sequence of values. Earlier in the section, a program called rand 3 times and output 3 different integers, right? Every time the program is run, those same integers will be printed. Such reproducibility is important for testing some programs. Yeah. Internally, the rand function has an equation to compute the next random integer from the previous one. All right. So the rand function, it looks random, but it's not really random because these so-called random numbers are predetermined every time. So if you wanted something that was more random, so internally the rand function has an equation to compute the next random integer from the previous one. For the first call to rand, no previous integer exists, so the function uses a built-in integer known as a seed. By default, the seed is 1. A program can change the seed using the function srand, srand2, or srand99. Okay. If the seed is different for each program run, the program will get a unique sequence. One way to get a different seed for each program run is to use current time as the seed. So the function time returns the number of seconds since January 1st, 1970. Okay. Note that the seeding should only be done once in the program before the first call to rand. So this program here is very similar to the one that we saw before, right? Except this time it's using srand instead of rand. So if you wanted a more random value, just use srand instead of rand and put time in as its seed. So that way you get completely different integers next time you run. Okay. So I think we have time to do this participation activity, and then we walk on here because there's time. So so question 1 says, the S in rand most likely stands for sequence or seed. Well, obviously it'll stand for seed because seed was the word we saw in this paragraph, right? Question 2 says, by starting a program with srand15 calls to rand, will yield a different integer sequence for each program run? False or true? I believe this would be false because even though we're using srand, we're using the same integer 15 with each run. The point of using srand is to put a number in the seed that isn't a fixed value, something like time, right? So I think it's false, right? And then question 3 says, by starting a program with srand times 0, calls to rand will yield a different integer sequence for each successive program run. What do we think about this? Is it false or is it true? Yeah, it's going to be true, right? Because we're using srand with time, which is going to be different for each program run. So I believe this is true. Okay, great. And then lastly, rand is known as generating a pseudo-random sequence of values because the sequence begins repeating itself after about 20 numbers. False? I think it's false too. Okay, perfect. Okay, so we've reached time here. I think, as always, the sections are very straightforward. What we don't finish, you can finish on your own time. Unless anybody has any questions about any... I know some people like to go ahead. Was there any sections that gave you trouble? Or is everything just easy? Because if anyone had trouble, we can address that here and now. No? Okay, well, so I guess I'll just end the meeting here now. This video shows how to get dark mode on code blocks. I hope it helps someone. All right. I'll go ahead and look at that video after this meeting, Michael Rubio Cruz. So.
Okay.
Okay, but if no one else needs any help, I'll just finish this meeting here, and I hope everyone has a good weekend. I'll be posting this recording later at night. So goodbye.